Okay, so continuing on then. So if you get this error, following parts need to be assigned a region. What it is, we just need to step somewhere. So you go down to regions. That is saying that has got to be assigned, and you'll see down here it's there's no parts in there. So you click on this one, select the back facing step, click OK, and that assigns it to the region. And then if you go back up, if you right click, execute, and now it should create the mesh. Okay, and then what we need to do is show the mesh. So we create a new scene, right click, new scene, mesh, and then we've got our mesh. Okay, so let's carry on. Yours will look like this if you put the correct geometry and everything in. Mine was a bit different because I just sped through it a bit. So we've got our volume mesh. Save it and move on to the next bit. So now we're setting up the physics. So we go to the continue. It might be worth just shrinking some of these things down. So that's all in the geometry, and it's the continua. So expand the continua. We'll have a physics node. If you it's saying to rename the physics to the fluid. So right click, rename fluid, and select these options. So we right click on models, select model, and you can select all the things that you're gonna actually solve. So we've already selected two dimensions already been pre-selected because we're running a 2D badge. We're going to select steady state. We're using air, which is a gas. We're going to solve it coupled. That automatically sets gradients. We're going to treat it as constant density, incompressible. We're going to make it turbulence, and we're going to which turbulence model we're going to use. Reynolds average Navier Stokes. What it's got down here, it's saying deactivate auto recommended models. Okay, so let's deactivate this one there. And we're going to do the co-epsilon. We're going to do the realizable one. We're going to have exact distance. Oh, I think I missed something there. Oh, that's that one. That's a high line possible treatment. There we go. And optional models. We're going to do the coupled energy. These might not make any sense. Don't worry. We're just going to run through. I think it's really just to show you all the different models that are there. You could easily just sort of run this for normal with the default models of turbulence. But anyway, so we'll just let it go. We'll select the coupled energy. I'm going to select close. That's all the models we need. It will run with other models, of course. And so now we've got all of those models in there that we're using. And then let's move on. And now we're going to modify material properties and set initial conditions. So again, it's probably, you can do this. I'm going to sort of skip through some of it. So expand the gas. And you can edit the material properties. And it wants you to edit the density. Change it to 2. I'm just going to leave it. Dynamic viscosity you can change. And again, it's telling you a value that you can change it to. You just type in and change it. Specific heat constants. So you can change all these values. Change it from 1003 to 1000, just to show you can do it. And thermal conductivity as well. So it's a good idea to change them, and then you'll get exactly the simulation that is appearing. But I'm just going to carry on with the default values. The next thing it's asking you to do is initial conditions. And so, edit the fluid initial conditions and select the following values. So, turbulence specification, intensity and viscosity, we want you to change that to K net epsilon. And then the dissipation rate, got a value there which you can change. Kinetic energy, again there's another value which you can change. And then the velocity. You'll need to change this one, otherwise it's not going to go anywhere. So I'm going to, actually it will work, but it will just start off at 0, but I'm going to change that to 1, so it's going in 1 meter per second in the X direction, 0 in the Y. Press return to put that in. And now it's wanting to set up the boundary conditions. Tools is right at the bottom. There's loads of different tools. I'm just going to quickly scan on and see what it's saying. Okay, yeah, so what this is doing, it's setting up the inlet data to an actual value rather than letting it run from 1. It's a good idea for you to do that. But I'm just going to skip through. So that will set up this velocity profile, and that means that inlet condition which is in the file. I'm just going to let it run on with normal values. The physics values, and then you can set up all this tabulated data. Again, it's a good idea to do that. And then there's a heat flux that you can set up as well. That's all in there. So you set up the boundaries for this bottom surface is creating heat. Okay. So the next thing after you've done all that is to prepare streams of visualization. So we go into this. Let's shrink some of these down. And go into our scenes. Create a scalar scene. So we right click. New scene. Scalar scene. And then we want to change the scalar value to, if we want, expand that node, and right click, we want the scalar field, and set the function, and it says velocity magnitude, so that's all the way down the bottom, V, velocity, expand this node, magnitude. Just make sure I've got that. I think that's right, yeah. Velocity magnitude. And then we are monitoring the wall shear stress, so let's create a plot. So right click, new plot, XY. And we'll rename that to that plot and click to the right of the part. So that's down here, parts, and we want to the parts that we want to put that wall shear stress on is in the regions, backward facing step, and it's the step bottom, so it's this one. So that's where we want to plot just on that region. Hit OK. And then we've got to select the Y type 1, scale function, and I'm going to set that fill function. So this is the data that we're putting in. I'm going to set the wall shear stress all the way down the bottom. Wall shear stress, and we just want it in the I direction. That's the X direction. We don't want it in the other two, so click OK. Okay, and you can do a similar thing for the Nusselt number as well, but I'm gonna skip that. So that's a plot. So yeah, by all means do the other plot as well. Let's set the stopping criteria. Maximum steps, it's 1,000. It's saying change it to 500, but I'm just gonna leave it. Let's save it. And then it wants us to modify some solver settings. So this current number is to do with stability. So solvers, let's open this one. Coupled implicit, and the current number. Coupled implicit. Current number. We change to 100. And we want scroll down, expert initialization. So change that one to grid sequencing. And then solution driver. Changing that one to expert driver. So that's just setting up some background. It should work without it, but let's do that. And then we're all ready to run. I'm just going to save it. Let's get on the residuals. Scalar. Oh, here's my residual plot. I'm going to put it on the scalar. Let's see what's happening. Right. Let's run it. Hopefully this will work. The residual plot, yeah, automatically loads up. So that's the solution running. This is the scalar feed. So this is the velocity magnitude as it's running through. So red is high, blue is low, and you can see the flow developing. Yours will look a bit different because you use the correct geometry. There's going to be a problem with mine because I've got some blue or some very low speed coming in the outlet. So I've actually got flow coming in to the outlet. So mine isn't going to run as well as yours. And that's just going to carry on running. Let's have a look at the shear stress. And there we go, there's the shear stress which is updating as we go. So we've got 0, let's just show you what that is. So we're doing, this plot is from here to here, and it's modelling the shear stress along here. So it's 0 flow at this point, so the shear stress is 0, and then there'll be a flow going along. So we've got 0, and then we've got a negative, which means it's actually you're getting flow reversal. and that flow reversal is maximum here. And there we go, the iterations have just stopped, and then it's actually, we're not quite, oh yeah, we're just getting a bit of positive flow. So you can see the zero line. This is, if you like, the recirculation region. So this, in this direction, the flow is going this way, and then we're just getting a reattachment just where the outlet is. So that's what this shear stress graph is. While you're here, I'm just going to put a let's just do a velocity scene so you can actually see it. Right click, capture, and there we go. So you can actually, here's the streamline, you can actually see this kind of recirculation zone. Unfortunately, I can't zoom in, but you can zoom in on yours and you'll see this recirculation. Okay, so let's see what the next one is. Oh yeah, so visualize the results. So yours will look more like this. So you've got the extra outlet, and you'll get this separation and recirculation zone. So yeah, mine looks different just because I was a bit lazy and I just did a quick mesh. But yours will look like this if you use the proper dimensions. Okay, I'm going to stop this recording there.